Hello, this is Gary Mitchell. Hello. Good. Just doing a mic check. We are going to talk about intermediate Power BI. We're going to see the structures for Power BI, both desktop and in the cloud, and also supporting technologies that make business intelligence possible. I'm going to put on the screen my email address, and I'd like you to write that down. It's gmitchell with two L's at Directions Training. That's Directions plural training.com. Two L's. And if there's anything I can help you with Power BI wise, be sure to get in touch with me. I'll put that up again later. So, the big deal with business intelligence, big data today is extracting, transforming, and loading data, ETL. We are going to use clients like Power BI to attach to servers like SQL servers and build data models. And one of the things that we'll see with data models is that it's an abstraction of the data, and it's also disparate data sources we can use, and we'll see what a huge amount of data we can access. This ETL process is pretty important, and it's about 75% of the expenditure of time and effort in a BI presentation. So good to get this down. When we talk about big data, there's no really such thing as big data. This is what most people believe makes big data, and data is big today and getting bigger every day. But we want to talk about volume. How much is there? Petabytes and terabytes of data, big data. And again, data is getting bigger and bigger every day. What's a variety or different kinds of data, text, photos, images? How quickly does this change? How quickly do we update or get new records in the velocity of the data? Variability, if it's read-only data, historical, no changes, we're not as concerned about that as maybe an OLAP cube that constantly is updated. And this is part of our job, the quality of the captured data. The higher the quality, the better that we look and the better that the end users can report on. I'd just like to revisit some technology. Some of you may be new to this, but when we talk about big data, we may talk about kilobytes. That's 1,024 bytes. I wonder how much that is. I wonder how much a megabyte is. That's 1,000 kilobytes. So buzzwords are huge and getting bigger and bigger and bigger. There is an illustration on this slide of binary counting. You can see, and you don't have to take this away with you, but you can see that a 1 and another 1 in the second place is a 3. So this is how we can make numbers, letters, pictures out of simple zeros and ones. And that's a little technical, but it's kind of interesting concept. This puts the size of data into a better context. A kilobyte, 14-line email, or a lengthy text paragraph, 1K, 1KB. A megabyte is as big as a full novel. Next size up is a gigabyte. 300 MP3s. We can relate to that. 40 minutes of video. Video is huge in the storage space that you will encounter. Terabytes, 30 and a half weeks of high quality audio. That's a half year of audio. So a terabyte's pretty big. Petabyte, everything on the web in the year 2000 was 8 petabytes. That's big, big. Not as big as a zettabyte, 300 trillion MP3s, if you could imagine that. 200 billion DVDs. So every day it's getting larger and larger, and there's plenty of planning for getting big. One of the processes that happens in business intelligence is that a company will have divisional level databases. And the division heads will be kind of selfish and not want to share that with anybody. But with the data warehouse, we'll roll up those divisional databases. We'll refer to them as data marts. And now we can look at everything in the whole company and make informed decisions about what to do because we have a data warehouse. That's generally an enterprise operation. Again, data mart is a division of the company, and a data warehouse is the entire company. It's a repository for everything connected to your company, and you can see that there are huge amounts of server centers all around the world that are full of data, and more and more and more every day. One of the things that you want to keep in mind is diverse sources. These data warehouses have Excel documents, they have text documents, they have Oracle, they have SQL, they have Hadoop, big data of many, many types. Another concept that's even bigger than a data mart or a data warehouse is a data lake. And the data that's in a data lake is unstructured. Whenever we put data into a database, we have rows and columns and data types. But in a data lake, everything is just thrown in unstructured, zeros and ones pretty much. And they will hold vast amounts of data and will be a source for analysis for enterprise level clients. Data lakes, data warehouses, big data. The new buzzword is data estate. It's all of the things that we've discussed previously. Everything that has to do with your data will be referred to as a data estate. Well, I want to put some data into my system. What can I include? Excel files. We're very familiar with using Excel for database analysis and calculations, making graphics, comma separated value, pure text. That's another kind of data that will go into data stores. Relational database management systems like SQL Server. SQL Server uses a language called Transact SQL, TSQL. You can see an example of TSQL script on this page. Use AdventureWorks Go, select this from production, not product. That takes some concentration, some understanding. This is another reason why Power BI is so important, because we don't have to learn in-depth computer languages and querying. We can use the user interface to do that for us. XML, JSON. These are a couple of formats of pure text. JSON being kind of the new guy on the block, JavaScript object notation, and it's getting more and more information in it, more usage than XML. ETL. Let's talk about data modeling. A model is an abstraction of data. It's not the data itself. So I'll leave the data alone where it lives, but I'll bring in a copy into my model. Then I'll manipulate that data and report on it in Power BI in the data model. So here's an example of the data model. I see some interesting acronyms here, OLAP and OLTP, and I'd like to take that to a little higher level. Back in around 1960, IBM was the big player in databases, and they had what we would refer to as a flat file. It looked like an Excel worksheet with rows and columns, 2 dimensions. This was a good way to do data transactions, putting in new records, changing those records, updating them, deleting records. So OLTP was good for a long time until we started getting these huge amounts of data, and a new process called online analytical processing, OLAP, evolved. As a multi-dimensional cube, instead of 2 dimensions, rows and columns, we can have up to 128 dimensions. So when I look at this picture, I see data sources, databases, and the word CRUD, create, read, update, and delete. The operations that happen daily happen on that database. We have a data model that's read-only. This means that we can make all the changes we want to in the data model, and they won't be reflected in the data source. We're not ruining any existing data. Well, once we built a data model and imported records to it, the underlying data sources will change. So from time to time, we'll need to update, and you can see a schedule refresh. This is a function of Power BI that will go and get the latest changes from your data source and load them into your data model. Excel has been used for years and years and years for intricate analysis of data. Power Pivot for Excel is an add-in that will allow you to build data sources and manipulate them, save them. It's not as sophisticated as Power BI, but if you are of the opinion that Excel is the way to work with data, you can do a lot of the things with Excel Power Pivot that you can do with Power BI. Well, I said that ETL is 75% of a big solution for huge data. What does this mean? Data cleansing. You may have in your data source duplicate rows. We won't appreciate that, and the data will take it out. Dirty data, errors. Some people have put in their data with all caps or all lowercase. We may concatenate data. We can make a new column in our data stores, and for example, we will concatenate the first name and the last name field to a full name field. Here's the question, what is 2 plus 2? You probably say 4. That may be true. A number 2 plus a number 2 is 4, but a text 2 plus a text 2 is 22. So one of the things that database engineers deal with is what's the data type for this particular column, for example. Filtering is a buzzword used to say, show me less data, give me specifically what I'm looking for. In SQL language, we use a where clause. Show me all the people in Chicago where they wear button-down shoes. So filtering is a big portion of this BI because you don't want to return every piece of data with millions and millions of rows. You want to be specific about what it is you're reporting on. Because there's so much data, we may find that some columns and rows are not, that exist in the data source, aren't needed in the data mart, in the data model. So we'll leave those out, and you can always go back and edit your sources and add them if you need them. But we want to make sure that we don't get in too much superfluous information. Here is a graphic that discusses OLAP, Online Analytical Processing, as opposed to OLTP, Online Transactional Processing. So, tabular, two-dimensional databases are queried with a language called DAX, which we'll see a little bit later on. There's a different language for multidimensional data cubes. Again, those cubes can have up to 128 different dimensions. And there's an MDX language for querying cubes. So a couple of languages to go along with TSQL and whatever else language you are going to implement. T, transform. We've got data, and we're going to make it right. We're going to clean it up and reset some of the parameters. Microsoft has a dedicated tool called SQL Server Integration Services. It has a pretty large curve for learning, but if you want to automate, say, daily data loads where you go somewhere, get some data, clean it all up, load it somewhere, then this can be, in large companies, is automated with SSIS, SQL Server Integration Services. And again, that is a part of Microsoft SQL Server, and it has a pretty good learning curve. Well, let's talk about Power BI now. This is the most important thing you'll probably come across. This is going to be the ultimate, this is the ultimate client for data servers, huge databases. The first piece is the desktop. It's a standalone application. It doesn't cost anything. You go to Microsoft and say, let me have Microsoft Power BI desktop. And it is a powerful, powerful tool for analyzing data, making visualizations, which you'll recognize as charts and reports. So this is working locally on your computer. The files that are generated by Power BI have a PBIX extension. One of the things that we may decide is, yes, I've been working locally here on my desktop for quite a while. I want to publish this so that people can get their hands on it in the cloud across my company. So there is another piece of Power BI that we can publish to from the desktop. So Power BI really comes in two pieces. If you subscribe to Microsoft Power BI Pro, and right now this is $9.95 a month, which is not particularly expensive. This is analysis and collaboration in the cloud. This is where you publish or push your data structures that you make in desktop. Once you've pushed data up here, you can make dashboards and save them and then share them with end users, with administrators. You have a lot of security involved here, but this is how you get it out of your system and into the world. Administration for Power BI is in Power BI itself, so you don't have to learn any new tricks to administer Power BI. Well, where can we get data for our data model? I see a huge list here: Excel, CSVs, XML. We've talked about this. SQL Server, IBM, MySQL, Teradata. Even cloud sources like Azure. And we can see there are several places in the cloud that we can get data from. Software as a service, services like Salesforce, GitHub, QuickBooks. You can also scrape data off web pages that is in a tabular form. Hadoop is open technology for huge database stores. Active Directory, Exchange, lots and lots of places to get data. There are third-party providers that every day there's 2 or 3 more added into Power BI. You can see some examples, but everything you want to get your hands on and more is available pretty much. When we make Power BI with a desktop on premise, we have a certain amount of operations. We may decide, I want to put some of my information in the cloud. And not only that, I want to work with the cloud data and the desktop data simultaneously. And we can institute a gateway that will allow us to have a hybrid solution, which means we can query both in the cloud and on the desktop in a single operation. Well, we get a lot of data, and it doesn't do us any good unless we can get some actionable intelligence out of it. A couple of buzzwords: forecasting. We're going to anticipate the behavior of a whole bunch of people, as opposed to predictive analytics, which says, here's one person. You have gone to Amazon or some web source and you see an ad that says, people like you bought this book or this software. So that's an example of actionable intelligence that we can get from large amounts of data. Another thing that I think is really handy is quick insights. When you generate a data model with disparate data sources, there's a whole lot of information there. And here's an example of how it may work. Some years ago, a chain of stores put all their sales records into a big database, and they used an algorithm to query it because it was just huge amounts of data that didn't make any sense. And they saw a 70% correlation in disposable diapers and beer. So when people bought beer, they bought disposable diapers. Well, these stores put both of them together close to each other, and they sold more of each. So that's a nice example of an insight. You can make your own studies, develop your own insights, but Power BI has got the ability to look at your data and tell you things that you couldn't see with your own eyes. Another thing that helps, especially people who are beginning Power BI, is the natural language query. So I might type out how many people live in Chicago. That is translated to a querying language, select star from city, where you don't have to learn programming languages. You can just use natural language query. Here is a big piece of this picture, and this is a concept of KPIs. The way this works is the big bosses don't have time to look at every piece of detail in the company, but they need to know the important things that are happening. So we may create a key performance indicator, and it looks like this. If our plant is making 100 cars an hour, then turn the traffic light green. If it's making 90 cars an hour, turn the traffic light yellow. And if it's making 80 or less cars an hour, turn the traffic light red. then we can make a dashboard with a traffic light for each plant, and the supervisors, the executives can just glance at a dashboard and see that this plant has gone yellow and get the fix for it. So here's an example of a graphic that is hooked up to a data store in real time, and as things pick up or slow down, then it is graphically recorded. KPIs on dashboards. A Power BI report. This is an example of a report, and I see a lot of different graphic representations here, visualizations, and I want to repeat report. There's many pages in this report, and there are many different visualizations on the pages. This is not what gets published to the cloud. We will push this report into Power BI Pro and then publish dashboards with this report information. We'll see that in a minute. So digital dashboards, that's our ultimate presentation. We publish a one-page dashboard. The dashboard, before you put report elements on it, is called a canvas. So we'll have one dashboard with lots of reporting objects in it, and we can then share that with end users, securely share it on the internet. Dashboards come from the Power BI service, the cloud piece, the Pro. You can't create dashboards in the desktop version. You can and will create the reports in the desktop version. Well, one of the real benefits of working this way, when you pull together a bunch of pieces like a data source, like some reports, like some dashboards, you may be illustrating an important concept, and with an organizational content pack, you can say, I want to package up all these things, the database, all the reports, all in one piece, and then I can share that with other people. They can't affect my underlying data, but they have their own copy of the data and the reports that they can use and improve themselves. Organizational content packs, very important product in Power BI. We can come to a much higher level of reporting by using Microsoft SQL Server reporting services. And this says this is part of Power BI Premium. This is not desktop. This is not Pro. This is a much, much, much larger implementation, Power BI Premium. We're talking about thousands of dollars here. This is like cloud elastic pools. You can have huge amounts of dedicated services from Microsoft just dedicated to your company. So we can have report servers for our own company inside the firewall. There is a concept of bring your own device. A lot of times when you go to work for a new company, they will say, we're not going to buy you a laptop or a computer. You buy your own. We'll give you some money to offset your expenditure. And more people pick smartphones as a client. So one of the things that we need to do is take our graphical representations and make them look correct on 20-inch screens, on 8-inch tablets, on phones. So built into Power BI, here is my report, make this look good on a phone. And that is a coming technology. If you decide that you want to subscribe to the premium level, you're going to get dedicated capacity, terabytes of data, multiple cores for CPU emulation. You don't have to purchase per user licenses. If you have a premium subscription, then the clients can just come and get what they need without using licenses. You can distribute dashboards, reports, and other content inside or outside your organization. You're going to have a dedicated capacity. You'll have so much resources that are dedicated just to your operations. One of the benefits of working with an elastic system like this is you can scale up or down as need be. You may be doing a huge product outlay and say, let me look at this. This thing is huge. I need this much space, this many resources. And then when I've finished that huge story, I'll say, okay, let's just drop back down and use less resources, charge me less. So Power BI is in the cloud. We also have on-premise, and we understood that we need a gateway to make the two work together. So here is the process. Here is how you would go through. You would create your data store. You may put in calculated columns, just like you would in a SQL server. Create measures. A measure is a scalar result. We might say, give me an average of all the sales. Give me the maximum sale. Give me the minimum sale. Those are scalar single value returns as measures. Data insights. All the data in the world won't help you unless you can get intelligible action out of it. Make some sense of it. And then when you pull together all the pieces that are required to make this understanding, you would then publish it with an organizational content pack. One of the things that we want to make available to you is a companion resource. And we put this together with 5 different tutorials for you to do all the data, practice data sets, the tutorial instructions are all in the resource pack, which I'll give you a link for in a few minutes. There's also outlines of the Power BI classes that we offer, and there's some white papers. They're not too involved, but it's a good place to start your research. So if you'll get in touch with your sales rep and say, send me the companion resource pack, then you can do these labs yourself. I talked about DAX. This is a querying language for two-dimensional data stores, not OLAP cubes, but OLTP, data analysis expressions. This is a scripting language, not programming. It's nothing to get nervous about. But when we say, I want to write a formula, DAX will give us structured results and say, okay, here's the column you want, here's the table you want. You have a graphical engine to do your reporting on that is using DAX underneath. And what this means is you don't have to learn the DAX language unless you want to do in-depth analysis. There is a lot of DAX that's written for you with the user interface. I am asking the question again, what is 2 plus 2? And the answer is it's either 4 or 22. And I notice that DAX can address 2 different data types, numeric or other. Numeric would be a number, and other would be text. So you're going to have to make sure that the query understands what kind of data you're expecting to access. So here's how DAX works. On the left side of the equal sign is a label. This is just a word. This is the title. This is a result. It's going to be printed on the screen. Equals, then the expression itself is on the right-hand side of the equal sign and is assigned to the result at runtime. So whatever you put on the right side of the equal sign is resolved and displayed as a result. It probably helps to get a little closer into that, and here's an example. Net sales, that is just the name of a column. It is just a text string. Okay, what is net sales? It equals the sales price column minus cost of goods. So I'll take the sales price, take out cost of goods, and I'll load that into something called net sales. So if you want to see the net sales, it'll be $10 million. That is a way to structure this query. The second way on the screen is the same thing, but it's a little more sophisticated and a better way of working. In the first syntax, there was an understanding of what table we were working in. This will work a lot of times, and sometimes it won't. So we are advised to do this. Net sales equals, what's the name of the table? Left square brace, sales price, column, close brace. So the table name is with the column in both instances, and this is a fully qualified reference. Now then, there can be no mistake which sales price column I'm talking about. It is the one in the annual sales table. So always use qualified references. We'll take a look at a little more advanced DAX syntax. And this particular operation is named product full category. So I think this is going to do something greater than just dealing with a category in our data. Equals, do what's on the right-hand side of the equal sign. Related is the first keyword. I'm going to work with two tables that are related to each other, the category table and the subcategory table. Okay? So the first open paren says, go to the product category table and get a column called product category. Close square brace, close quote. And that is a concatenator, and that's going to take the value of that string, which is a dash, and then say product subcategory. So this is going to say product dash category. We're relating two tables together, getting a column from each table. Here's another example that is probably easier to understand and makes a lot of sense. What are net sales today? It's the sum of the sales amount in the sales table, okay, minus the sum of the discounts. There's the value. And then minus the sum of returns. And when you've taken out your discount and your returns, then you'll have net sales. So this is an expression, it's a DAX expression. And again, sometimes we'll do this, sometimes we'll use the graphical user interface in Power BI to do this kind of work. Okay, I'm going to see if we have any questions here. It's looking like No. Good. If you would like to get the content pack for this class, if you will email your account executive, and if you don't know who your account executive is, you can email sales@directiontraining.com, and we'll send you a file. We'll send you actually a link to a file, because a lot of times you can't get big files in your email. We'll send you a link to download the companion materials that will have 5 different tutorials, data for those tutorials, and for you to just practice and play with, and some reference materials. Again, if you have any questions while you're working with these tutorials, send me an email. I'll put my email back on the screen, and I'll be happy to help you with any of this. Power BI is one of the most important concepts that has come along in a long time. It is a powerful client, and Direction supports it with a lot of resources, and we have several courses that delve deep into Power BI. I'm going to put my email address back up just in case you came in late. Mitchell, 2 L's at directionstraining.com. Plural directions. So don't hesitate to get in touch with me. If you will get in touch with your salesperson and download that companion material, I think we can help you get your Power BI education started. This is the end of the presentation, and I really appreciate you giving me the time to go into Power BI and how important it is. Thank you.